before we begin lesson 10 for unit 6, we are going to wrap up lesson 9 with this video that we did not get to finish during class.
With lists, we can begin to store lots of data, and we can also think about writing code to process that data. For example, a list of the pixels in an image can be processed to change their colors to give the image a unique filtered look. A digital song file is actually just a list of waveform samples and can similarly be processed to apply digital effects. We know that computers are great at repeating commands in the form of loops. So when we want to process every item in a list in a similar way, we can use a loop to iterate through every item and take some action with it. Let's look at how we use loops to process lists. First, we can make a while loop to run a specific number of times by using a variable called count. This loop will run 6 times. We also know that lists have numbered indexes starting at 0, and since the variable count stores a number, we can use count as our index into the list. And since count changes every time through the loop, starting at 0 and going up by 1 until 5, this gives us a mechanism for accessing every item in a list. An easy first step when processing lists is to write a loop that prints out all the values in the list to make sure you are seeing everything. Let's do that here. We'll add a console.log statement in the loop and make the loop condition more general by removing the hard-coded value 6 and replacing it with the length of the list. Now, if the list size changes, our loop will still print everything out. Let's run it. This kind of looping structure, one that uses a variable to control the number of times the loop iterates, has 3 basic components to it. Creating and initializing a variable to use as a counter, some condition that checks the value of the counter each time through the loop, increasing the value of the counter by a set number for each iteration. This kind of structure is so common that many languages include the for loop to do just that. The for loop combines these components into a single line of code for convenience. The standard setup of a for loop looks like this. There is a lot going on here, but you can see it has the same basic components as the while loop above. It creates a counter variable called I, while I is less than 4. Add 1 to I every time through the loop. You might read a for loop out loud like this. For variable I starting at 0, while I is less than 4, I++. You can think of I as shorthand for index, and I++ is shorthand for increase the current value of I by 1. The value of I will come in handy when we use it to access each item of the list, just like we use the counter variable in the while loop. Note that I is just a convention and you can name it anything you want. Let's look at an example of using a for loop to go through every item in a list and doing something with each item. Here we have a list of red, green, and blue values for a very small image. We could brighten it up by adding 50 to every number in the list. In each iteration of the loop, we are getting the current value stored in the pixel list at index I, adding 50 to that number, and then updating the value at that same slot in the list to the new value. So the first time through the loop, I is 0, pixels at index I, or pixels at 0, is 28, 28 plus 50 is 78, pixels at index 0 is updated to be 78. The next time through the loop, I is 1, so pixels at index 1 will be accessed and updated in the same way. This will happen for each item in the list. With a for loop and a list of values, you have an easy way to process all of the items in a list. This is a foundational concept in computer science you will see over and over again, and it unlocks the power of dealing with lots of data.
All right, so let's move on. So we want to remember that a traversal, this is a noun, is the process of accessing each item in a list one at a time, okay? The verb form of that would be to traverse, all right? And that's going to be going through each item in a list one at a time. So now we're going to investigate traversals, okay? So, quick review. How does the traversal machine work? All right, this is your index number, okay? And when index is 0, whatever index 0 is on that list, that's what's stored in the variable, okay? And then every time I increases, the index value increases, all right? Think back about what we did yesterday. Ask your neighbor if you don't remember. If you were not here, there are copies of the traversal machine hanging on the board, and you can get a copy and your neighbor can show you how to put it together. All right, now for our activity. All right, you're kind of sitting in groups of 4-ish, okay? So you're not moving, all right, unless someone who is supposed to be beside you is absent. So kind of get with about 4 people and then go to level 1 on code.org, okay? On level 1, I want each of you to read through the entire code, okay? And then I want you to decide as a group who is going to focus on which function, okay? So let one student focus on the average function, one student focus on the slow function, one student focus on the fast function, one student focus on the numbered list display function, okay? Read the code for those functions, all right, specifically, and then explain how that function is working to the rest of your group, okay? Now, the goal of you discussing this on level 1 is to give you the opportunity to see lists traversed for different reasons and with different outcomes. So you should look at the code for your assigned function and make sense of what the function does overall and how it does it. So pause the video here until you have done this and then come back. Now, how does your function work? What list does it use? How is it traversed using a for loop? How does the app work? Talk about that as a group. Pause the video and then come back. Now, with a neighbor, both of you doing it on your own computer, but discussing it with a neighbor if you need to, create a function that adds together the total time of every element in the list. Use the console.log to get the result or to display the result, and call this function in the update screen function. So that means whatever function you create, you're going to call it within the update screen function, probably at the end. All right, so pause the video here so that way you have time to do that, and then come back and continue. Now, with a neighbor that you did not move to get to, you're going to navigate to level 2, read through the code, and run the app, okay? What looks new on this app versus the previous app? Okay, open the data tab and investigate. How does the app work? What information is available? What can you change? What can't you change? Investigate a few different data sets, all right? And answer those questions for the ones that you investigate, all right? Pause the video here so you can do that, okay? The goal of this investigation on level 2 is to give you an opportunity to make sense of how traversals and the data sets can be used together to create a working app. It is important to know that the algorithms in this app on level 2 have some of the same qualities as the algorithm that you will need to develop for the create performance task for the AP exam, okay? So pause the video here so you can run through this and investigate it.
Hi, my name is Ariana, and I'm going to show you how to use the Data tab in App Lab. When viewing an App Lab project or an App Lab level, you might have noticed that there are 3 tabs: the Code tab, the Design tab, and the Data tab. When you click on the Data tab, you'll be taken to a data library where you can see different categories of data sets that you can use in building your programs and apps. You can click on a category to see the different data sets within that category. Click on a specific data set to see a little more information about that data set. When you click on More Info, you'll be taken to a different page that tells you more about the source of the data, any cleaning up of the data that may have happened, and information about each column. You can also click this Preview button to see what columns are included, as well as some of the data that's in your data set so you can see if you're interested in using it. Click the X at the top right to return to the Data tab. Any of these data sets can be imported and used in any program or app that you're building. Before you can use a data set in your code, you'll first need to import it. Let's say I wanted to import a data set in the geography category, like this US states data set. When I click on the name, I have the option to import by clicking on this orange import button. Then I can click on the name on the right to preview. Now I can see all of the data in columns. Any of these columns in any of these data sets can turn into a list in your project's code. If I wanted to, I could make a separate list for every column here. Once I've imported, I'm ready to use the data in my code. I'll click back to Data and then click over to the Code tab. The first thing I'll do is create a new variable that will hold a list. I'll call it State Names. Now, to get the data from the Data tab into this list, I'll go over to the Data drawer and pull out the Get Column command. Next, I select the name of the table I've imported. Now I can pick which column I want to use. I'm going to pick State Names, but you can choose any of these down here. Because Get Column returns a list, meaning it gives you back a list, you don't need to create a separate list. Notice there are no brackets here. When I print out what's in this list, you'll see that we have a full list in the console log. Notice the bracket and all 50 state names in this list. Once you have this list in your program, you can use it just like any other list. So you can traverse over it, filter it, or anything you might do with another list. And this allows you to make really exciting, powerful, and interesting programs.
All right, so now what you're going to do is you're going to modify the code. So choose a data set and import it to your project. Look at the code, check out the data drawer in the toolbox that will give you this one block. Okay, modify the block to print out a column of data from your chosen data set. And I believe you're doing that on level 2. Now, go to level 3 with a partner and follow the directions on the screen. Read the code very carefully. Yeah, that's not what's on level 3. Okay, level 3 is this. So this is level 2, the random dog picker. All right, follow the instructions when you do level 2. All right, level 3. This is the list filter pattern. So if you want to filter a list, this is code that you're going to use. Okay, this is what it would look like in blocks. This is what it would look like in text. Okay. If you wanted to filter a list using the length block, this is what it would look like. Well, the length, filter it based on the length. this is what it would look like in block text, okay? And we looked at that kind of earlier in class, list, and then the index value dot length. All right, this is what it would look like via text. Now, if you're filtering multiple lists, all right, this is how you would do that in block code, and this is how you would do that in text, okay? So once you have looked over level 3, go to level 4, all right? This is a list reduce average, all right? This is for list reduce for the smallest, how it would look in block versus code. And then this tells you how it works. All right, so look over those. Make sure you understand how it works. Whenever you get finished, complete the check for understanding on Schoology, and you'll also have some other answers about, some other questions about this lesson to answer.